All right, for this graph, what we're going to do is we're going to make a table for ourselves. So you get some x and y values. The y is just the h of x right here. And yeah, they may use different lettering there, but we're just going to make a table. And we're going to figure out some values that we can put on the graph. Of course, these are all ordered pairs for us. And sometimes it's nice to start with the y-intercept where the x is 0, because working with an x value that's 0 makes things pretty easy. So what are we going to do? Well, we're going to take that x minus 3. So we got x minus 3 that's squared. That's what my y is going to be. But now we're going to replace that x with 0. Okay, so again, we're going to solve this. Y equals, and by the way, this is something you could put in the calculator, but you should get a y value that's 9. Now, there's kind of a problem with this because I can't actually fit this on my graph. You could, if you're just doing this by hand, you could just say, well, I know 9 would be about up here, right? And that's my y-intercept. But since that didn't work, we got to keep going with other values until we can get it on the graph. So I'm going to put an x value in that's 1. And then I'm just going to work the equation again. Okay, so again, my y value should be, instead of x, we're going to do 1 minus 3 to the power of 2. And that's going to be negative 2 squared, which is still going to be a positive 4. Now this one I can fit into my graph, right? 1, 4 is going to put me right there. So that worked with x is 1. Let's try x is 2 and see what happens there. So we're going to say x is 2. So that'll be y equals, in parentheses, it's going to be 2 minus 3 to the power of 2. And that's just going to be negative 1 times negative 1, or negative 1 to the power of 2, which is going to be 1. And again, this is going to fit, so we'll put that in. Next, we'll just show that you could do a 3 if you wanted to. Y equals, 3 minus 3 to the power of 2, and that's just going to make y is 0. So it gives us this ordered pair here. Now, I made a bit of a mistake because I do want to continue my table. I can kind of see that it's kind of dipping, or it's slowing down how fast it's going down, which means that we should be able to try another value. So again, I'm just going to keep going up by 1s there, and now I'm going to try x is 4, so that'd be y equals, we're going to go 4 minus 3 to the power of 2, and that gives us y equals 1. So I have another ordered pair at 4, 1. And again, the reason I don't want to go backwards now from 0, because if I tried an x value that's negative 1, I'd get y equals, negative 1 minus 3 to the power of 2. That's negative 4 times negative 4, which is 16. I can't even put that on this graph, which means that we have found the vertex. So the vertex is the extreme. It's either the maximum or minimum in our parabola. And I can see it's the purple point right here, which means that my axis of symmetry is going to be right through there, and it's going to be a vertical line this way. And what you'll also probably want to notice is that the points are kind of a reflection from each other. For example, to the red point is 1 unit to the left of my axis of symmetry, and it has a reflected point, which is that green point. Which means that the blue, which is 2 units to the left, its reflection would be 2 units to the right from that axis of symmetry, which is going to give me that point right there at, it looks like 5, 4. Now we can check, right? I forgot to put my 16 in the table. We can check, so I'm going to come up here. Again, what would happen if I put an x value that's 5? Well, you'd have y equals 5 minus 3, all that to the power of 2. And that would give you 2 to the power of 2, or 2 times 2, which is 4. That is the ordered pair that we just put right there on the graph. Now, that's all I can put on the graph, which means I'm now ready for the line, aren't I? So I'll use red here. And I don't know, the way that I do this, it's not great. But again, I'm trying to get to that black point up there. So, something like this by hand. I just need to get through those points, and it doesn't have to look pretty, but something like that is just fine. Again, we're looking at this red parabola right here. It's going to go up here, and by the way, the black point, which is 3 3 units to the left of the axis of symmetry would have another corresponding black point over here, 3 units to the right from the axis of symmetry. Not that we can put that on the graph, but that at least completes this one. Again, all we're doing is plugging and chugging on this one. Now, there is a different way to find your values on this, and that's to use your calculator. And now I'm using the TI-30XS Multiview, which is the one that I've recommended to the class. If you don't know what that is, again, you can just Google it and buy one. But you could also go to the announcements, which is where I put that. In any case, here's how you're going to put this into the calculator. All right, what you want is, even from the calculator, what you want is a table like this one, although it should be a little bit more orderly. It should look a little bit more pretty. So first up, what we want is to push a button, right? So the first button you're going to push, and this shouldn't come as a surprise, but it's a table. You're going to push the table button, which is 3 buttons up from 9. It'll say table right there. Now when you push table, it's going to show y equals on the screen. Okay, and you're going to have the cursor right here. It's going to be blinking, blinking, blinking. And all you're going to do is enter in the equation exactly like you see it. So of course, the next button you'd push would be open parentheses. Then you'd push the X button, which is 1 button to the left of 4, minus 3. Then you'll close the parentheses. And then to get that power of 2, you just push the X squared button. Now on your screen, you should see this exactly, which of course, it's not going to show h of x because we're using a y. But this is telling the calculator, use this equation to give me x and corresponding y value. So if you push enter, now what it's going to do, it's going to say start. So it's saying, where do you want this to start for your x value? I would want to start at 0 because that's kind of where I started. Below that, it's going to say step. Where do you want the step to be? Just at 1. Again, this means how far do we want each x to go up by. And just like we have in our table over here, I just went up by 1s. And then underneath that, it'll say something like auto. And then it'll say ask x, like this one. We just want auto on this one. So pretty much all I do, because mine is already set up this way, is just push enter, enter, enter. In the bottom right, you're going to see okay. Yes, it's okay. And right off the bat on my screen, this is on my screen. Okay, you got x, y, and then mine showing 0, 9, 1, 4, and 2, 1, which, by the way, is an exact match of these 3 values right here. So how can you see the other values? Well, all you got to do on your cursor is press up or down. And so if I were to continue to click down, I see 3, 0, 4, 1. And if I continued, I'd see 5, 4, 6, 9, 7, 16, and so forth. I could go up as well. Back to -1, it's showing -1, 16, -2, 25, -3, 36, and so forth. Of course, none of those fit on my graph, so I'm not really worried about that. But at the very least, I now have a way to do this on my calculator. On exam, of course, you're going to want to show work if you want credit. So, you know, show some work, do something. Again, anything in this range is good. You could just show the table if you'd like. But again, you need to show some work for the exam. This is a nice way to use these calculators to help us out because it saves us a lot of time in these calculations. And since our exams are timed, you're definitely going to want to save some time by just throwing this in the calculator and then just writing the table on your exam. So thanks for watching, you guys. Hopefully that helps.